All right, welcome everybody to our presentation today on collecting blood and antibodies from saliva in the COVID-19 era. This is an effort to help people get their field research in population and behavioral science research back in gear after all the disruptions we've been through in the COVID-19 complications. So today I'm gonna tell you a little bit to begin with about some of the options that are out there for remote biomarker collection, particularly in the context of blood. Heather McCreath and Jessica Crocker from UCLA are gonna provide some essentially sort of tips and tricks for how to actually make this right, how to help participants collect blood for us as effectively as possible. Jessica Fall from the University of Michigan in the Health and Retirement Study is going to talk about their experience collecting antibody data from participant saliva in the Health and Retirement Study. And then at the end of the presentation, we'll do probably about 10, maybe if we're lucky, 15 minutes of essentially an open question and answer, in which case people can ask questions that may not have been covered in the rest of the presentation, help clarify anything that we might have mangled on the first class and that sort of thing. When you do ask questions, please use the Q&A feature that Zoom offers. If you're not familiar with it, you should be able to find it on the pop-up panel in the bottom center of the screen. You'll see Q&A. If you can type your questions into that, then our Master of Ceremonies will compile those and essentially ask them of the relevant speakers at the end. We'll also have probably brief just clarification question and answer at the end of each presentation section. So if there's anything unclear, just ask us to clarify them. So without further ado, I will dive right in. I'm Steve Cole, along with Eileen Crimmins and Teresa Seaman. I'm one of the co-PIs of the USC-UCLA Center on Biodemography and Population Health. We're also involved in the NIA network on the measurement of biological risk. And we are going to share with you some of our experience helping essentially survey researchers. Previously were mostly interested in this kind of thing. Now we're all in this boat. But what we've learned from survey research trying to get biomarkers into population health research, and particularly the prospects for taking what we used to do with survey administrators and actually have participants take up the slack and do the sampling on their own. So we'll start with blood data collection. As you are all probably aware, it is possible for study participants to collect their own blood, particularly in the context of dried blood spots. That's traditionally how this kind of research has been done. If it's not possible to get a phlebotomist out to your participant, you can either have the participant or a survey administrator basically prick a little hole in the fingertip, and as the blood comes out, you can collect it onto filter paper. Filter paper essentially spreads the blood out and allows it to dry out very quickly, which seems catastrophic from a sort of a normal biology standpoint, but actually turns out to work out pretty well for stabilizing a wide range of blood biomarker parameters, or what in the assay community we would call analytes, things that you're interested in assaying. The reason this works is because the drying process actually inactivates a lot of the water-based and the enzyme-based processes that would otherwise lead to breakdown in various proteins and chemicals and other constituents of blood. So this actually is a surprisingly preservative general strategy. Typically, the way people have done this in field research in the past is they generate essentially a do-it-yourself kit of supplies, including the alcohol wipes you need to make sure it's done sterilely, some gloves to make sure that you don't transmit infections, and the lancets that you need, little needles, typically spring-loaded, that will pop a little hole in the finger without causing too much pain. It is possible, though, these days to use prefabricated kits for this kind of thing, as well as little kits, little devices essentially, that allow the participant to drip blood not onto filter paper sort of one drop at a time, but into little vessels. So I'll show you more about this in a minute, but this is one of the devices for that kind of thing called a HemaSpot, where if you prick a hole in people's fingers, you can drip the blood into the center of that little clear plastic reservoir there, and it will dispense the blood onto a little filter paper that has this kind of asterisk or star shape in the bottom, is kind of suspended so it can dry out easily. In all of these cases, we want to help the blood dry, ironically enough. And so we typically will be most concerned with letting it air dry and then putting it into some kind of relatively airtight container like a Ziploc bag, along with a desiccant pack. The desiccant pack absorbs the moisture and essentially ramps down as far as is feasible the ongoing so-called hydrolysis and enzymatic activities to essentially preserve chemicals and antibodies and other kinds of proteins in their easily assayed state. Less familiar to people in general is a wave of new devices for collecting blood that don't involve sticking holes in your fingers, which is not terribly painful, but still not that much fun, to tell you the truth. So a number of folks have been trying to transform blood sampling to sort of get around the requirement for a phlebotomist, but still allow self-collection through what you can broadly call microfluidic devices. These are, I guess, to put it not so kindly, little plastic vampires that you can stick typically on your upper arm, and they will take blood out much less painfully, it turns out, even than finger sticks. They generally involve microneedles, typically an array of them, which are barely perceptible compared to sticking a bigger needle into your fingertip. So these microfluidic devices, like the one shown on the right there, typically adhere with a sort of a adhesive ring to your skin. They typically need something approaching an airtight adhesion, but the microfluidic manufacturers have gotten pretty good at that. And there's a couple of different mechanisms of action that I'll describe later, but the dominant mechanism of action now involves using the micro needles just to poke holes in your skin. And this sounds gross, but it turns out to work pretty well. Once the needles pop back out of your skin, blood leaks out of your skin, pours down your skin, and falls by the force of gravity into a little reservoir at the bottom. Sounds horrible, works fine, looks a little ugly, but actually it turns out is more reliable than a lot of the other strategies that people came up with that involve, for instance, trying to suck blood out through the microneedles using vacuum or things like that. Once the blood comes out, there are a couple different dispositions you can get in various different devices. One of them, for instance, collects wet blood, essentially, that then needs to be returned to a laboratory for an assay. One popular device for that is called the TAP. There's a second generation device that is particularly popular these days because it doesn't cause very much pain, collects wet blood, and so you can do lots of different kinds of assays using that, but with some constraints that we'll talk about in a minute. There's another device called drawbridge that when it pulls the blood out, actually dispenses it onto one of these pieces of filter paper so that it dries out, much like a dried blood spot would. So this is a dried blood spot that's essentially coming out of your arm instead of your fingertip. There's another device, actually two devices made by Tasso, the M20 and the SST, which would allow you to collect either wet blood or dry blood spots, depending on your preferences. So I'll show you a little bit about that as an example. First, though, let me show you the HemaSpot device in a little bit more detail. This is the one that is designed to help people essentially collect data from fingertip. And you can see the reservoir there with a little hole in the middle. The blood drips through the hole, falls on that star-shaped piece of filter paper like this, and that star-shaped filter paper wicks the blood out with lots of edges for it to dry out with, and that helps that helps basically speed the desiccation process, speed the sort of extrusion of water and the denaturing of the enzymes that would otherwise lead to kind of breakdown in the chemicals. So it's pretty simple. You drip the blood in, wait a minute for things to sort of start desiccating well, and then you can close the lid right then and ship it to the little container actually has a pack of desiccant in it, so you don't even need to worry about that yourself. And the HemaSpot manufacturer makes these nice, handy little packets that not only include the HemaSpot device itself, but the alcohol wipes and lancets needed to actually get the blood flowing, gauze to stop the bleeding, bandages to band-aids to sort of patch everything up at the end. And they wisely include enough material for 2 tries, which is a good idea, as you'll hear later when people start talking about kind of practical what works and what doesn't topics. This is the Tasso device. Again, this is one of the microfluidic devices that essentially sort of pokes a little ring of microneedles into your shoulder skin, and then blood filters out through, in this case, these little microchannels that divert it into those little 4 bubbles there that are actually little chambers for making blood spots on a piece of paper that you can see as kind of a tab sticking out of the bottom of the device. So you would pop that on your arm with, after prepping it, and then just essentially put it back in the package and mail it out. They can also sample wet blood. There's an adapter for that kind of thing where you pull out wet blood. You can separate it into serum versus cellular components, actually in a microcentrifuge in your lab, so pretty easy to work with. There's a couple of other devices that are broadly similar in microfluidics in terms of drawing blood out either using vacuum or this kind of a gravity draw microneedles device. I won't go into too much detail on these. These are all broadly similar. They all seem to work reasonably well. We'll show you some data for one of the devices in a minute, just verifying that it kind of cross-validates the way it should. How would you go about choosing among these different devices? There's 3 major things that matter. The first is, what are you trying to assay? So we can't tell you what biology you should be interested in, but some biomarkers are easy to assay in dried blood spot form. Other biomarkers really need fluid blood, typically plasma, sometimes serum. So in general, if you need wet blood, then you can, obviously use the microfluidic devices to draw that kind of thing. But there is a disadvantage that I'll talk about in a moment to that. Otherwise, if you don't need wet blood, it's generally to your advantage to use dried blood, both because it's cheaper, and for the moment, in a moment, I'll talk about kind of biologically why there's a disadvantage to having wet blood, especially if the participant needs to return it to you through the mail. But there are some disadvantages to the dried blood spot versions. They include less total volume of blood and a little bit more kind of biological noise. So we'll talk in a few moments about how to manage all that kind of thing. The issue with wet blood is that if your participants are going to be drawing a blood sample and then putting it in the mail back to you, that blood is going to be wet for quite a number of hours, typically a few days, sometimes in some areas of the country right now, a couple of weeks. So wet blood cells are still alive, but as time goes on, they become progressively less happy. After about 2 hours, there's a lot of red blood cell lysis taking place in wet blood, and that is interpreted by the immune cells as damaged tissue. And so you get all kinds of inflammatory responses to that kind of thing. If time is too long, you'll end up with hypoxia under certain circumstances. And both of those will cause the biology of the blood to change from the state it was in originally in the body. So that's what makes dried format blood collection better than wet, particularly for things like plasma cytokines or RNA that could plausibly be ramped up and produced de novo by cells once they're out of the body. Some biomarkers need temperature control. Jessica Fall will talk to us about how they've managed that in the context of antibody data collection from field sites. So that's a manageable issue as well. But one of the things that you need to take into account, because it is one of the drivers of this kind of shipping drift that takes place as participants are mailing samples back to you. So I covered this before. You might seriously consider, if you're doing data collection in a localized environment, to actually have your research assistants recover these samples in person or by using some kind of a TaskRabbit-like courier service that can help you retrieve the samples instead of letting them wend their way naturally through the mail system. There are also some cost versus convenience trade-offs. So lots of people focus on the expense of the devices themselves, and some of those microfluidics devices in particular are a little bit pricey per unit, like in the $20 to $50 range. But there are some trade-offs for that price in terms of convenience. So there's an array of different options. I won't go into too much detail, but just be aware that non-device expenses often dominate the total cost of biosampling. So be sure when you're considering the options that you're interested in to account for the cost of shipping out and back of the sample in the collection kit, account for the cost of staff time in the shipping operations itself. Some of these microfluidics and just general logistics services will actually do that work for you. So you can actually send devices to them. They'll ship them out to your study participants. They'll pick up the devices when the sample's been collected and return them to either a centralized repository or directly to your laboratory. So be sure to check in on that kind of thing and see whether that might actually, in the long run, be less expense and hassle than paying your own staff to do this kind of thing. Also be aware that there are differential assay costs for these different sampling modalities, particularly for dried blood spots, which have a smaller sample volume just physically, and so as a result end up being a little bit more expensive to assay. One of the other issues that's less concerning now, but just be aware that it's out there for some devices. Some of the older first generation microfluidics devices depended heavily on the ability to create an airtight seal and a vacuum on the skin. Their vacuum mechanisms had an expiration date on them. Most of the microfluidics devices are now trending away from that kind of mechanism, so it's not so much of an issue right now. But be sure, if you're working with one of these microfluidics devices, that you verify what its expiration date is, so you can take that into account in your ordering system. Okay, so with that, I'm gonna actually turn it over right now to Heather McCreath.
We have one quick question.
Oh, sure, happy to
about whether the microfluidic devices are appropriate for use on infants.
Most of them are not, but I wouldn't say they're impossible. As you might imagine, for regulatory purposes, no device manufacturer wants to say you can use my devices on infants. As you also know, we have a long history of poking needles into infants' heels to get blood spots that way. So my general, the more I think about it, the microfluidics devices aren't going to work even for young kids because they need a contact area with skin that I think is bigger than you can find a flat spot on most infants for. So I would say probably not in first pass. That said, you could potentially talk to some of the device manufacturers. There are some devices that look like they might plausibly be there, but I think most of them are going to be hesitant to do that because they're all trying to do this regulatory dance with the Food and Drug Administration, and so they're really inclined to say, nope, can't do it for anything other than our official indication with the FDA. Okay, I'm assuming Teresa will interrupt me if there's any more questions. Otherwise, let's head on out to Heather McCreath, who will tell us a little bit about how to actually get blood out of people effectively. What are all the practices, tips, and tricks that make that thing work?
Hello, everyone. Happy to be talking with you today. And I just want to also thank Jessica Crocker. We put this presentation together. I'm going to be the one who's mostly talking, but many of the ideas here are hers. So we have actually not conducted self-collection of dried blood spots, but we have many years of training with a variety of data collectors in a variety of settings. And so our suggestions here are exactly the things that we would think through as we were planning for a study. So Steve, yep, thank you. So, so when we're thinking about this kind of collection, what we what we want to know is that there are three things that are important for successful collection. And so we want to focus on thinking about these ways. How can you make sure that you've got maximum blood flow? How can you plan for there to be errors or problems? And then really thinking about the specimen handling after collection. So Steve's talked about some of that already with the way that we're thinking about shipping. Next slide. So when thinking about this, we thought that these were some areas to really rethink some of our standard protocols. And the choices that you make for the suggestions that we're going to be making really have to do with two things for your study. First, how critical is the dried blood spot? Is it a primary outcome? Is it a secondary aim? So do you have to get a specimen from everyone to make your study successful? And second, you best know your population of participants. And depending on the study that we're working with, we know that some participants would be more comfortable with certain approaches than others. So we think it's important to provide the instructions multiple ways, multiple times, and we'll talk about that a little bit more. When we're thinking about supplies, we need to think about collection and return, as we've talked about already, and also allowing for that incomplete first attempt. And then finally, one of the things that we found really important is to explain to people why you're asking them to do these different things. When you explain the rationale, they're much more compliant. They're much less likely to skip steps if you tell them why it's going to either make it easier for them or in general make it more successful. So when thinking about ways to support participants, we have the following suggestions. First, some kind of printed visual aid that comes in the packet with the supplies. That's all important. Any of us that have, done our colorectal cancer tests know that it's really helpful to have some of those pictures there on a piece of paper when you're trying to figure out what you need to do. Second, it can be really helpful to have a video that folks can watch in advance of the collection. It's too hard to make the video be something that they use while they're collecting, but it shows them and walks them through the steps. And Steve will have some links for some videos that other studies have created already that can help this. Third, we think that scheduling a phone call or a Zoom call during collection can be a really great way to support participants. You can coach them, you can respond to questions, and then this will have hopefully the effect of increasing compliance and completion. And then finally, calling them back after you know they've collected them to be sure they've actually put things in the mail. It doesn't help us if it's sitting on their dining room table. All right, next slide. So when thinking about supplies, you want to suggest to people that they have a warming source ready. So this could be a heating pad, it could be a hand warmer. You may choose to send a hand warmer in your kit of collections, in your kit of supplies, or warm water for washing. Then we think it's important to include double supplies. And in case someone needs to redo the collection. We also think it's really useful to have drapes, or at least let folks know that they should have some paper towels that they can put down to protect surfaces. And then finally, it might be helpful to suggest they have a family member or housemate be there with them to help. And if so, it would be good to include a pair of gloves for this helper. So when promoting blood flow, there are, on these next two slides, we're going to talk about different ways that you can promote blood flow. So first is hydration. We want to make sure that people are well hydrated with room temperature water, and you need to have them start this 10 to 15 minutes before. We also want to make sure that folks wash their hands. This has two rationales. One is to make sure that their hands are as clean as possible. But this is also a way to promote blood flow. And so you want to suggest to people that they use water as hot as they can tolerate. And then you also want to indicate that instead of just rubbing hands, that they're actually interlocking their fingers to stimulate blood flow. Then you want to think about both the temperature of the arm and hand and stimulation of blood flow. So again, as we've suggested already, using a hand warmer, perhaps allowing up to 10 minutes for the heating, and possibly massaging the hand and arm during collection. Then finally, one element that we have found invaluable is to ask gravity to work for us. So you'll see sometimes pictures where people may be holding their hands at waist level or perhaps table level, and their hands may be up a little bit. What we really want to encourage people to do is to have their hands hang as much as possible. So they might want to dangle their hand either during warming or at least 1 to 2 minutes after warming. And then depending, you may have folks be able to actually hold their hands at lap level for sampling rather than table level. I suggest you just try it yourself and feel the blood in your fingertips, and you can immediately see a difference. Now, when collecting drops, this is something that is the hardest to train in collection, and so it's where there's most likely to be errors for participants. You want to emphasize that the blood should drop and not be blotted. So again, pictures, specific examples of why, and here we're providing the reason why you want to have that happen. And then you want to avoid overlapping drops. You can't use spots that overlap, and aiming for the circle can be difficult, particularly if you're doing it yourself. Many of you have seen the kinds of Whatman filter cards that have 5 circles on them. We suggest that it might be smart to just tell people to do every other spot so they can hit every other circle. That means if they miss a little bit, you're not going to get an overlap. And it's better to have 2 separate cards if you need more than 3 drops than one card that has spots all over the place. Next slide. Thank you. And then after collection, we want to think about 2 things. We want to think about a safe place for the specimen to dry. As Steve's already described, drying is very important for effective and useful specimens. And you want someplace that's open, away from spills. We've had that happen for sure. We've lost a specimen because somebody knocked over a glass, but also away from kids and from pets. So we provide 2 options here. Either ahead of time, you can instruct somebody to find some sort of box that would work, or you can potentially find a foldable box that can ship flat and then be assembled by the participant. And then you need to look at your return mailer, and you need to think about not only the DBS card, but potentially all the lancets. I do want to indicate that a lancet is a sharp, and at least in California, you need to be careful about how you dispose of that. We're still investigating some of the ways in which that can be done, but it may be that you have a small container that you have the lancet go into, and that goes in the same container with your card to ship back to you. Thank you.
All right, thank you. Teresa, were there any questions for Heather there?
No questions at this point, thanks.
All right. So just a couple of sort of follow-up points on Heather's and Jessica's presentation there. Participant support for self-collection is going to be the key to making this work, because obviously you're not going to train an RA to do this once. You're going to be training each new study participant to do it. So there have been some people who've been pretty successful at this. I can tell you all of the things Heather said, absolutely true. The one thing that's really kind of transformed the industry is videos. There's 2 general formats in which you can support your participants for actually doing the draws themselves. One is many of the device vendors actually have made their own helpful videos. So here's links to one for a microfluidic, one for a HemaSpot, sort of dried blood spot, finger dropping techniques. But what really works best, if you can possibly pull this off, is to create your own custom study branded video, particular for your own study. So here's an example of one of those from Ohio State. Very, very well done, incredibly well communicated, great visuals and graphics, and seems to have been pretty successful in helping participants actually figure it out and get it done. The reason the custom study branded videos have advantages is, one, they can provide much better coverage of the particulars of your study and the sort of the quirks. You can also embed links in the video so that they can contact your live support, as Heather mentioned, having a phone bank or Zoom office hours or individually scheduled Zoom, sort of coaching is a huge accelerator of, adherence and compliance and success in getting samples back. And then also just being able to remind people about why they're in the study, why they joined in the first place, and how important it is that they're helping you learn what you're learning can be huge, not only in motivating them to actually do the blood sampling, but also in just maintaining engagement with your study in the first place to maximize participant retention amidst all the chaos that's going on in life these days. We've already covered this. There are a wide variety of mechanisms. We think it might actually be helpful to have more than one of these mechanisms operating at a time so that you can pick up the planful people, but you can also pick up the impulsive, I want to do it now and get it done with people. So consider having multiple options. And then as Heather mentioned, there's some regulatory issues out there, particularly if you're shipping wet blood, you're going to need to meet a federal Department of Transportation standard for essentially double-walled containment. Dried blood spots themselves, once dried, are considered non-hazardous, but wet blood needs to have specialized collection. So, basically don't just tell them to throw their, tube in whatever mailer they can find and send it in. That's going to get you in trouble pretty quick. As Heather also mentioned, it looks like, at least in some jurisdictions, we'll need to return the lancets used for poking people. That's an area that is under active consideration because the idea of sending lancets through the mail is itself kind of crazy. So there's a little bit of inconsistency here. One of the things you can do, though, is you can look to the vendors for the latest guidance. The vendors are highly motivated to get regulatory compliance as high as it can be because they're on the FDA's radar right now. So, for example, Tasso and HemaSpot manufacturers have regulatory FAQ pages on their website that can help you sort through all that kind of stuff. So you've gotten the sample. Does it actually work? Well, the headline is it works, but it works best if you attend to a few kind of details and issues. First, the upshot is you can get just about anything that you can get out of a normal venipuncture blood sample somehow out of either microfluidic wet blood sampling or out of dried blood spots. So one way or another, just about everything you can get technically can be assayed. However, it turns out some things work better than others, and everything works better under certain circumstances than others. And so we're going to try and give you some kind of advanced perspective on what those issues are so you can manage them in your own study. But just to a first approximation, just about everything you can conceive of, somebody has measured somehow out of dried blood spots or microfluidic samples. Here's an example of a frequently used biomarker for metabolic function, particularly in the context of diabetes studies, hemoglobin A1C, run by a team that has quite a lot of experience in this. This is actually published out of the USC-UCLA Biodemography Center's research group, showing that if you, sort of collect data using the standard venipuncture assay and in parallel collect data by dried blood spots, you can find actually a pretty tight correlation, a correlation about 0.99 in absolute magnitude. So that looks pretty good under the best of circumstances. Some analytes are highly, highly reliable. Here's another example in the context of a recent popular topic, assaying antibody levels for the SARS coronavirus 2 in the context of COVID disease monitoring and population health surveys. So on the left there, you can see that it validates quite well with respect to PCR testing. In other words, if we've got people who PCR says have active infection, they're also showing the expected higher levels of antibody. You can see again a pretty tight correlation between serum-based measures of this and dried blood spot-based measures, again in the hands of one of the most experienced researchers in this area, Tom McDade's group at Northwestern University. You can also get genomics-based data out, either for transcriptome profiling, for RNA measures, or you can do genotyping out of these kinds of samples. And again, results correlate reasonably well by, sort of with venipuncture blood samples. You may feel like 0.72 correlation out of dried blood spot is not that super awesome, but it's better than having zero correlation because you didn't collect any data at all. And so in a moment, we'll talk about how to kind of overcome the higher noise that is just intrinsic to some of these sampling modalities. But the take-home point is it is feasible, and if you do the analyses and study design and technical noise management in the right way, you can actually get pretty good success. So here's the big issue, particularly with dried blood spots and to a lesser extent with microfluidic devices, and that is, in general, we're going to be getting less blood than we would have from standard venipuncture blood samples. And the implication of that is less smoothing of both biological variability and less kind of being centered in the sweet spot of the assay method itself. So typically, if you think about this quantitatively, dried blood spots, you're going to be doing probably about 50% higher signal to noise ratio, higher, sort of, let's say, replicate variability and coefficient of variation. Typically for these microfluidics, you'll be closer to maybe, sort of 25% greater, 25% poorer signal to noise ratio or higher replicate variability. That is intrinsically a byproduct both of the greater difficulty assaying these smaller volumes, but even more so greater biological variability, just because you're smoothing over a smaller biosample in the first place. So kind of by law of large numbers, you just don't get quite as smooth results. There are some additional complications that come from, sort of, you can think of them as the quirks of human physiology that end up stressing even more so the assay system, particularly things like hematocrit. So you can see dried blood spots there coming from people with just simply different densities of cells in their blood. So on the left, you can see someone who's got very few cells, a lot of plasma, but not a lot of cells. And that kind of variability across the individuals is going to end up being variability in your data set. So trying to make as uniform as possible the amount of hydration in people, for example, through the methods that Heather was talking about, turns out to be helpful at this stage downstream. One of the other important things that you can do to deal with these situations is just take it into account when you're powering your study, bump up by 25 to 50% the sample size if feasible, and that will allow you to essentially kind of smooth it out on the data analysis side, even if you can't manage the intrinsic issues. Another thing you can do is collect data on the performance of your sampling and shipping system and take that into account when you are doing data analysis, and also implement techniques both in terms of training participants and in terms of managing sort of data collection in the first place that can help you avoid compounding this intrinsic biological noise with additional kind of study procedural noise. And we'll talk a little bit about that in the next few slides. Finally, another thing you can do is make sure that the assays are actually performed by a lab that has a fair amount of experience with these small volume samples. There are several labs we'll point you to on a slide at the end that are sort of long experienced and sort of nationwide, to some extent, international go-to labs for doing, for instance, assays of dried blood spots or other low volume samples. one of the advantages they have because of their volume is they tend to run higher sort of, just routine quality control monitoring. And so they have a better sense of when manufacturers have changed antibodies in an ELISA or something like that, that if you're only doing the assay 1 or 2 times a year or something like that, you may not be as aware of it. So high volume has some advantages, both in terms of experience and in terms of their ability to sort of suppress what you can think of as assay level technical noise. And then finally, in data analysis, there's a couple of hints. I won't go into too much detail in the interest of time, but to make a long story short, there are things you can do mathematically on the data analysis side to also reduce the intrusion of what we'll call spurious unwanted nuisance noise into the data set, so that you've minimized the total noise down to sort of the minimum necessary due to biology or these other kind of assay challenges. There are also issues with the lower limit of detection. So because you're assaying a smaller number of molecules of whatever analyte you're going after, you're always going to be in the lower range of what the assay systems are used to or optimized for. So that, again, has a sort of an implication mostly for not pressing your luck and believing that you can achieve numbers smaller than you actually can. So most of it has to do with kind of trimming your claims and being careful in data analysis. Here's how to avoid compounding the noise problem. So Eileen and Teresa and the rest of the UCLA Center have spent a fair amount of time auditing different assay, different procedures to determine what leads assays to be noisy and what leads them to be reliable. One of the biggest drivers, and this is actually recently published in a paper that Eileen did with, I believe, probably the Health and Retirement Study, possibly, where they were looking at dried blood spots and the various procedural variations that take place. As Heather mentioned earlier, things like overlapping or smeared blood spots are considered suboptimal, having multiple drops. Various kind of, you can think of them as anomalies relative to the ideal of a dried blood spot. It turns out the thing that is most uniformly damaging, the thing you'd like to minimize as a study team, is the incidence of small suboptimal size blood spots. So here's an example. The spots at the top are about what you'd like to see on your dried blood spot. When you're getting down to 40 or 30 microliter spots, incompletely filled, spot perimeters, that's when things start to get dicey. And then when you're down there really at the bottom with, sort of only partially minimally filled spots, I can tell you that is total chaos for every assay that you're going to want to do. So the most important thing to do is to make sure that that chaos data doesn't contaminate the rest of your data set by having somebody actually look at these spots when they come in and give them a score. The score doesn't need to be fabulous. It could just be optimal versus suboptimal, or you could do, a 4-level score like the 4 you see there. By collecting data in the process before you actually punch up the cards or cut them out to do the assays can be pretty helpful down the line. The other major thing besides assessing spot quality and taking it into account in data analysis is minimizing shipping time, particularly shipping time out of the freezer. There are some analytes like C-reactive protein or hemoglobin A1C that are relatively robust to this kind of thing. We've had pretty good luck with RNA, surprisingly enough. But there are lots of chemicals in particular that do not preserve well over time. So once you get past about maybe 1 to 2 or 3 days of shipping time, you're out to 4 days, a week, 2 weeks. That's when you can start really seeing significant drift from the original value. So the final interpretive caveat I'll leave you with is that traditional venipunctures sample venous blood, finger sticks sample capillary blood, and these are not the same things biologically. So you'll want to take that into account. They are pretty similar at the level of protein and chemical content. So differences there are generally pretty modest. Where the differences are biggest is if you're looking at something cellular as your target. And that's because capillary blood has more solid tissue cells in the mix, as well as more localized influences. So for example, if you're taking the finger stick from a finger that's already infected, obviously you're going to get a little bit atypical results relative to what would be there in the rest of the body. So avoid sampling from atypical tissue is one of the easiest ways to manage that. When it comes to data analysis, we generally recommend against trying to just pool together venous and capillary blood data and analyzing it as if it was all one system. Much better to either carry out stratified analyses where you're testing your hypotheses separately in the two different strata and then trying to integrate them together either meta-analytically or through some kind of parameterization of blood sampling modality. And it's particularly important not to confound your study variables of interest with the distinction between venous and capillary blood. So the upshot is it works. It's not ideal, but it's better than nothing. It will get you back in business. If you know about its limitations, you can take those into account and do even better than nothing. So you can approach quite closely the ideal situation in many circumstances if you have a lot of experience and you know what to take into account. All right. I guess, Teresa, any questions?
We do have one.
Yes.
Would the TAP and other microfluidic devices be venous or capillary?
Generally capillary.
And then, Alan, do you want to unmute yourself and make your comment? Alan Potter?
Yeah.
Or,
Hi. Why don't you read it, Teresa? I have this echo going on.
okay. So I'll read the question and then Heather put a note up that she wanted to answer. You said to address the DBS spot size, etc. issues could be helpful prior to mailing DBS to receive a photo during the Zoom of the front and back of the DBS card to ensure that a full-size spot has been collected and filter paper is saturated versus a new DBS card. Heather?
Yeah.
I had nothing to add. Thanks.
Okay.
All right. With that, let me turn it over to Jessica Fall from the Health and Retirement Study to tell us about their experience with remote data collection on antibodies in the context of the Health and Retirement Study.
Thank you, Steve, and hi virtually everyone. Today I'm going to talk a little bit less about COVID antibody test in particular, because I know last week you talked a lot about the technical parts of those methods in different tissues. So here it's going to be less about the why and a little more about how we got to where we did and how we're actually doing it, because for us it involved both a new collection device and a new shipping method. Go ahead, Steve. So for us within HRS, we needed to come up with a test that was well tested and had good sensitivity and specificity that could easily be self-administered and used with a field collection protocol and the associated delay in processing. So we coordinated with Bharat at the University of Minnesota, his Advanced Diagnostic Research Laboratory, to help us come up with a strategy using an ELISA format. Go ahead. So the first thing we had to figure out was how we were going to collect it. So we had done venous blood collection in the field prior to this, and that is what's normally used to collect serology for antibody tests. But obviously it's not ideal for population-based screening applications when you can't go into the field yourself, because it's difficult to collect. People can't do it themselves, and it usually requires more expedited processing than we thought we'd be able to do here. In our sample, we usually get about 65% of people consent to a venous blood collection. So this would be a separate visit by a phlebotomist at their home. But again, because of in-person restrictions during COVID, this wasn't an option for us. Next. DBS, I know you guys talked about last week, is also an option, and we did this in our survey for a decade. For the most part, we had done interviewer-assisted DBS collection for all the reasons we talked about today. Just a lot of technical issues that we were working out during that time about how best to collect it and what the effects were on assays downstream. We had really good consent when we have an interviewer there assisting, and some issues with quality. And the one time we had done it in a self-administered mode where we had mailed a kit to people, we got about a 50% consent rate for self-collection, and that was among diabetics. So for this purpose, we were a little nervous about going that route again because we wanted a higher response rate than we achieved with our one attempt at self-administration for DBS. Next. So then we decided to turn to saliva. We routinely collect saliva for DNA, so we have experience here. We get a really high consent rate. It's usually quite easy for people to do. And we thought if we could get a valid COVID antibody test with some sort of salivary fluid, this would be the easiest for respondents to administer on their own. Go ahead. So what we ended up using was an OraSure kit. This is an FDA approved kit for the collection of viral antibodies. It's obviously amenable for self-collection. It's quite easy to do. It only requires a few minutes. And technically it's not a saliva test. It's an oral fluid collection kit. So that little blue stick has a sponge on the end of it. And for the best method of collection is not just to stick it in your mouth, but actually to swipe your upper and lower gums 5 times on each side, top and bottom, and then hold it in your mouth for 2 minutes to absorb extra fluid. And then you put it back into that container and break off the stick. And it has a lid and some fluid on the inside to preserve the sample. It's a relatively inexpensive kit. It's only about $4. Go ahead. So the advantages here were that it was easy for the respondent to administer themselves. It's inexpensive. We were able, with Bharat's help, to achieve the same sensitivity and specificity as blood. It has a low limit of detection. So similar to blood, you don't need a very concentrated sample in order to detect the antibody you want. The only thing we didn't know was the shipping stability. So the manufacturers of the OraSure kit say that it is stable at room temperature for 21 days. We've learned from experience never to believe those things, so we tested it ourselves. And I think Bharat talked about it last week, but the gist of this was it needs to be cold. So you lose about 20% of your sample if it is at room temperature, but you can remain fairly constant if the sample is held at 4 degrees Celsius. So that is what we needed to achieve with our protocol. Go ahead. So we did a lot of testing before we decided what our protocol would be. We assumed we would use 2-day shipping to try and get it from the respondent's home to the lab in a fairly expedited way. So we needed to figure out how to keep this sample at 4 degrees Celsius for 48 hours. We did a lot of testing with various combinations of freezer packs and insulated envelopes or styrofoam coolers, but we were never able to achieve more than a 24-hour temperature stability at 4 degrees. So we couldn't get to the 48-hour goal that we wanted to. We also had concerns about asking respondents to freeze the specimen in gel packs overnight. That would have been a slightly bigger ask other than to just collect a sample and ship it back to us. And we didn't know how compliant they would be, whether they have room in their freezers right now, or if that was even something that they were willing to do. So we needed another option. So what we found was a refrigerated shipping system called the NanoCool device. And this is a device that can keep samples cool, so from 2 to 8 degrees Celsius for 48 hours. And there's no need to freeze in advance. So that silver package you see there is essentially a cooling engine. It's very easy to activate. Steve, if you advance, you just flip the device over and press the button at the top, and that starts the engine. Go ahead. And then you know that the engine has been activated because the blue NanoCool label goes from white to blue. They also have an extended version that's available that can last 92 hours. So we pilot tested this device quite a bit, and every single one of our samples lasted to 48 hours, if not beyond, with just the standard version. Go ahead. So ultimately, our COVID antibody kit includes the NanoCool device and a styrofoam cooler that the device fits snugly on the top of that cooler. It acts like a lid, so people get a lot of information about what we're asking them to do and some instructions. And then they collect their specimen and repackage it in the box they received it in with this NanoCool device activated and on top. Go ahead. So both UPS and FedEx use this device. Neither one of them owns it. NanoCool is its own separate company. So we went down both paths to figure out which mailing company we would use. UPS was more responsive to our inquiries and less expensive for us. UPS is a preferred vendor with the University of Michigan, so that could be a different setup at your institution. The NanoCool device, well, the box plus the engine costs $40 for the 48-hour version. And like I said, the box is reused for the return shipment. Go ahead. So the protocol for delivery and return for us, the UPS is actually sending a designated truck to us every single day for pickup of about 600 kits per day. Go ahead. The respondent will then receive their collection kit at their home. On the first day, they will call a special 1-800 line at UPS for the same or next day pickup at home. So we've prepaid for the return shipment back to the lab in Minnesota and the cost for a home pickup. There is the availability of a Spanish language line. And so this is a special returns line. This isn't just calling, UPS, the general line. This is a special line for projects like this. So right now, online requests are not possible. The respondent then on day 2, or whatever day their sample will be picked up, will collect the sample, start the NanoCool engine, repackage the materials in the box, and put everything on their porch to be picked up. We are returning everything overnight instead of 2-day. Again, that was just a decision we made because the cost was the same as shipping 2-day for whatever reason. So we decided to go the more expedited way. So in total, we're spending $25 per person for shipping. That doesn't include the cost of the box. So like Steve said, a lot of times non-device expenses dominate the cost of biological collection. So again, the OraSure kit only costs $4, but obviously it costs us a lot more to get the sample kit to the respondent and then back again. Next. The thing that we learned in this process is actually just how fabulous UPS is. They have a new focus on healthcare research now that I didn't know. So healthcare is a new strategic initiative for them. And our decision to go with them in part was because they gave us an entire team to work with. So we have an account manager. There's a person on our team who is a special thermal packaging analyst, meaning they specialize in the NanoCool device. We are working with someone from their corporate healthcare strategy team. We've got their business services and marketing support, a technology support supervisor, and then a local business manager who's the person we're working with to arrange all the pickups for us at the University of Michigan. So they have been with us from our initial planning and continue to meet with us to monitor our progress in the field. So I have to say, I was shocked to have this much support coming from the shipping company, because that has not been our experience in the past. So this is definitely an area they want to get into. All of this is to say, we are in the middle of this right now. It's a really big operation for us. We're shipping out 18,000 kits in about a 6-week period. Basically, we've taken over the entire Institute for Social Research, so it's a good thing nobody is there because we have boxes everywhere. And we've hired a lot of people to help build the kits and coordinate all of this shipping. So anyway, I just want to give a shout out to them. Thank you. I do want to add one thing too. So the NanoCool device is really snazzy, and it solves a lot of our kind of cold chain control for protocols that need to have specimens remain cold. One caveat is that in our experience, UPS is not an option for shipping wet blood. So that again is one of these regulatory issues that might change, and so it's definitely worth inquiring, with your shipping company about what types of biospecimens they will and won't ship. So, thanks.
That wraps up the structured part of our presentation. I think what we want to do is open it up for questions and answers, and you're all welcome to stay, but our hour is up here, so we will not hold it against you if you take off and have lunch or have a great afternoon. Thanks for your time and attention.
There are no questions right now.
Can I just add, we are trying to assemble as much information as we can about things that are successful, or things that are not successful. So as you begin to work with this with your studies, please shoot us a note and let us know what you have found to be effective. That's the great thing about having this kind of community, is that we can learn from each other. So all that detail Jessica provided us is fantastic. We're already beginning to think about how we can make some use of it. So please keep us in the loop.
So there's a question, Jessica, would UPS not ship wet blood even when packed in styrofoam and double layered?
My understanding is no. They will not. They will ship dry blood spots and saliva, but they won't ship whole blood.
All right. So there's a question about what was last week's presentation, and I can answer that. So we had 3 presenters last week on measuring COVID-19 antibodies. And that is available on our website. And Bridget Gooseby asked again, will this presentation be available? And yes, it will be on our website. It takes a few hours, but it will come up later today. I'm not getting any more questions. So maybe we want to sign off?
Sounds good to me. If you guys have any more questions.
Oh, there is one
They're
question from
Yeah.
Rosie Shroud. Yeah.
Yeah. When doing daily studies, can participants send all their dried blood spots for CRP back at once at the end of the study, or do they need to send the spots back each day? That's a good question.
Yeah, so for CRP, the prospects are better. I mean, nobody wants to say, yeah, that's the best thing to do, right? But the reality is CRP is pretty stable. There's lots of particularly chemical analytes, especially in the area of cholesterol, which are not stable. And so you wouldn't want to do that. CRP, you've got a better shot. That said, I wouldn't push your luck more than, a week or something like that. So it depends on your study. If you're thinking of 6 months of collection, probably not the best way to do it.
Even a week is starting to get long.
Yeah.
We've all learned.
So the trick for saving this stuff, we have done pretty crazy things. Like we had an anthropologist collecting stuff in the backwoods of Nepal, and it was going to take a month to get out no matter what. And the key to this is the Ziploc bags and desiccant. So the way to maximize the odds of success there is just to make sure that they don't leave the spots at room temperature the whole time in the room. The best thing to do is to retire the spots into a Ziploc bag with a desiccant each time you draw, basically. And once they're in there, they're relatively safe.
After it's completely dry.
Completely dry.
Completely dry.
Yeah, or you can use those
If
HemaSpots, which have their own desiccant.
Alan Potter has done millions of dry blood spots, and I'm sure if he were not echoing, he would come on here and echo quite loudly about all of these things.
Yeah.
We have gotten many notes from Alan about bad spots coming to him. And it matters. So I think maybe we can sign off. Thank you, everybody. We're gonna.
And the URL at the bottom will have the video later. Thank you all for your time.
Thank you.
And good luck with your research.
Yes.
Bye.
And we are here to ask questions of and